So in this video, I want to talk about volumes, and specifically how to find volumes of weird objects like the thing I have to my left using integrals. So to the left, we have some sort of flower vase. So shout out to PersianHandcrafts.com for this picture. So let's discuss how we can find the volume of that. So first, let's start by defining our y and x axis, and we'll define some curve f of x, and we'll say that this curve looks something like this, and you'll see where I'm getting at in a couple minutes. Just keep watching for now. So I'll define the curve to be something like that. Actually, let's make this a bit better. Maybe something like that. Now, what if we take this curve and we rotate it around the x-axis? Pause the video here and think about what happens. Alright, so I'm assuming you've had a go at it, and I'm assuming this image gave you a little hint. But if we rotate this curve that we have around the x-axis like this, we end up with something like this. I'm going to try to draw it out a little bit. Draw out different radiuses at different points. It's a bit hard to visualize, but I think the image we have to the left helps visualize this a bit better. So something like that. So I think you get the idea here. And so if let me actually draw the reflection of this curve. Again, this is not perfect, and I think the image to the left makes this a lot easier to visualize. But if we rotate this around the x-axis, knowing the function f of x, we can find the volume. We can find the volume of this three-dimensional object. So before I get into it too much, the math of it, I wanted to just conceptually introduce this. And the formula you can think of would be from the integral from a to b of the area of some function dx. So in this case, the area we're talking about are these little circles that we're making. And notice that the radius of these little circles changes as a function of x, right? Changes as a function of x. So maybe we can rewrite this as the integral from a to b of pi r of x squared dx. So again, we're going to get into this formula a bit in the next video, but I encourage you to just think about what this means. This radius here is a function of x, right? And what we're doing is we're taking every infinitesimal area of these circles and adding them up from from some a value to some b value, and that gives us a volume. And in the next video, we're going to do some examples to make this much more concrete.